Hey everybody, my name is Boo, Community Evangelist with DevCentral, and I'm joined by Jason Rahm as well, Community Evangelist, also with DevCentral. And today we have on guest Kevin Jones. Kevin is Senior Product Manager with the NGINX group at F5, and he's also kind of our local resident Web3 blockchain crypto expert that we've had on with us on DevCentral a number of times at this point. And recently he's written an article around security when it comes to decentralized applications, Web3 type applications. And so, Kevin, great to have you on to chat about this today.
Yeah, thanks for having me. It's really great to be here. Thank you.
F5 being a security company, we are always looking at ways that we can help protect the world out there on any sort of applications, generally a lot of consumer-based applications, Web3 being kind of peer-to-peer. Everybody's a consumer at that point of that application, as well as participating. So maybe you can talk through a little bit around the current state of security when it comes to Web3, because we have seen some attacks when it comes to blockchains now, right?
Yeah, I mean, when it comes down to it, I think one of the biggest things about Web3 and this new concept of how you deploy applications is decentralization. So with decentralization comes kind of like more points of attack, right? You have a distributed set of nodes, and then on top of that, with the concept of smart contracts, where you deploy a smart contract, which is kind of like infrastructure as code, literally, that you deploy and is duplicated and spread across the network. Those smart contracts are really acting as kind of like the application logic of your application. So it's very important that you have kind of strict security in mind when you're dealing with smart contracts, because those smart contracts actually are acting as a bank and they're holding monetary value as well.
So the code for the smart contract, maybe we can break that down a little bit. You have the blockchain is deployed across all of these nodes. Where exactly does a smart contract fit into all of that? Is a smart contract like part of the addresses, or it's just built into the node, the code of the node itself?
Yeah, so when it comes down to like blockchain-based applications, and more specifically, I guess we'll talk about like Ethereum. Everything you do is like transaction-based, which is kind of like message-based. And so you broadcast a message or a transaction on the network. And so when you deploy an application, that's exactly what you're doing. You're taking a copy of a smart contract, which is just application logic that's inside of a written code. It's compiled down into what's called bytecode, and then it's sent in a transaction to the Ethereum virtual machine or to the network. And when it's received by the network and you want to then interact with it again using that message protocol, using the transaction-based protocol, you are doing so with use of what's called an ABI, but basically you're making a transaction against that and accessing the functions and the variables and the state that is inside of that contract. So you can think of the contract, and then it's duplicated across the network. So you can think of the smart contract as a distributed set of instructions that are duplicated across the network with consensus or whatnot.
On the defense side of things, are we finding that the existing defense techniques that we use are just adapted to that environment, or are we needing completely new defense techniques?
Yeah, well, so I think it comes to a mix of both kind of Web 2 and Web 3 technologies that we're seeing, specifically with like these type of applications. People are still utilizing maybe Web 2 for certain things, for like off-chain data. And so we're still like, obviously very important that we kind of monitor like typical like HTTP, denial of service, right? All of the standard kind of security level stuff. But then on top of that, I think what's really important about Web 3 and like especially Ethereum-based applications or smart contracts is that you do a really good job at auditing the code, because there can sometimes be things like underflow or overflow problems with the code, or there can be issues where there's not strict access control for certain parts of administration functions in the smart contract. And so I think what the most important thing is that you're keeping an eye on how the code is written and making sure that there's no like susceptible loopholes or vulnerabilities in that code.
That code, is that compiled each time there's a transaction and it's the smart contract is sent out? Like, is it updatable, I should say?
Well, it depends on the deployment pattern. So there are what's called the proxy protocol, or a proxy deployment protocol, where you can actually deploy a smart contract behind of another contract and then upgrade it. But in most cases with Web3, you deploy an application with the idea in mind that that's kind of like that version of the application. And if you're going to rewrite the application to add features and functionality, it's probably going to be more of like a V2, right? There's not usually minor upgrades in Ethereum-based applications, because they're kind of costly to deploy as well too. So when you deploy an application, it does cost a little bit of gas or upfront processing power to be able to distribute that application across the network. And so when you deploy your application, you want it to be in as solid of a state as possible, and kind of carry it with you in that sense. And then if you need to upgrade it, you deploy a second version usually, and let your users know, like, hey, this is the newer version of the protocol.
Well, and if you're watching this and you don't understand what gas is and deploying this, in our last talk with Kevin, we actually got to go through a demo of that. So you have to go check that out. We'll drop that here in the comments below.
Yep.
Yeah, absolutely. Actually, you provided everybody with some examples of building a Web3 application. So using that example, is there ways that people might look at that and look at how the code is built and maybe, practice safety or security hygiene?
Yeah, so I think the best thing you can do as far as security goes when you're writing like a smart contract is actually look at like previous hacks or previous issues that have arose from like kind of smart contract vulnerabilities, and then try to not replicate necessarily, but figure out ways of like how you might avoid that kind of thing. Like an example would be, underflow and overflow is a common issue, or still is a common issue with smart contracts. If you're using newer versions of certain compilers, it usually has protection against that kind of thing, but it's still kind of possible in certain scenarios. So it's probably a good idea to again, look at existing hacks that have happened in the last few years, and just kind of look at the code for that and see where the vulnerability was, so that when you're writing your application in the future, you can kind of learn from those mistakes and kind of build in rules and special security layers for problems like that.
Yeah, I was looking at this one hack. It's like $570 million in a cross-chain attack where the smart contract was they had a bug in the bridges smart contract, allowed hackers to forge transactions and send money back into their own crypto wallet. And so from your perspective, what's most susceptible at this point? Is it the on-chain, off-chain, cross-chain? What area is needing the most attention right now?
Yeah, I think it gets riskier, right? Anytime you introduce like another chain. So I think if it's a cross chain or like a layer 2, usually there's this, we call it bridging, right? In the sense. So it's when you're bridging funds from like a layer 1 to a layer 2, or really a layer 1 and a layer 2 are really cross chain. Layer 2 is usually used for like the term of scaling. So you're trying to like scale the network. Cross chain might be a completely different protocol usually. So like an example would be if you somehow wanted to bridge like Ethereum to Bitcoin and vice versa, and like kind of make collateral funds across the networks, then that's more like kind of cross-chain. But I think, again, it gets more risky in that sense. So I think that's probably a very important aspect of security. But I also think that, for most of the innovation and things that are happening, a lot of that is starting to happen on layer 1s. And so the smart contract security is also still obviously very important, because there's a large amount of settlement of like, Ethereum or other layer 1s on those same systems, right? So I think they're both equally important, but I think there's more risk with like the layer 2s and the cross chains, right? Because you're relying on a completely different network or completely different chain that could have its own vulnerabilities tied to that, as opposed to when you're dealing on the actual primary chain, you're just worried about the actual smart contract language and any vulnerabilities there, right?
One of the points that you had in your article, you had a couple points of different types of vulnerabilities. Maybe we can chat about a couple of them. One of them is poorly implemented access control. And so when you talk about that, and I perceive the blockchain and layer 1 and layer 2 is open. And so where does access control, authorization, authentication actually play into that?
Yeah. So, I mean, of course, the concept of like the actual network. So like in the case of Ethereum, like it is an open network. Anyone has the ability to interact with that, the protocol, and anyone has the ability, as long as they have a public and private key, in that sense, it's open. But when you're actually designing smart contracts, there's a popular framework that you want to use. It's called Ownable, or Open Zeppelin makes a specific contract that you would want to inherit the behaviors of that ownable contract. And it allows you actually to take ownership of a contract. And you can build off of that and do things like what's called multi-signature, where you can have multiple owners that take part of a contract as well. So there's like Gnosis safe. And you can set rules for like how many signers need to be able to call certain functions or set up certain kind of like transfers. And so that's where we talk about access control. Like sometimes people deploy a smart contract with one private key that's on their phone, and then their phone gets hacked and anyone can get access to all of the funds. And maybe they didn't set up the ownership properly, or maybe there were certain functions that weren't set up with proper ownership. And that led to some kind of attacker maybe draining the contract, right, of any of the funds that are in there. So it's a combination of using access control pattern inside of the smart contract, and then on top of that, using something like multi-signature, where you have a trusted set of keys that can sign transactions to do different things. And that's what we see like commonly in the terms of like DAOs or treasury management for like DAOs or large companies, is they use multi-signature.
And maybe another one here, I'm wondering about transaction front running. And so what you're explaining here is that if somebody has knowledge of upcoming transactions, maybe we can elaborate on that a little bit. Like what can they do with that knowledge?
Yeah, exactly. So, the concept of when you're doing this transaction-based kind of interaction, there's a certain limitation of how many kind of transactions can fit into a block on the blockchain. So how that is combated is there's what's called the mempool. And the mempool is essentially like a list of everyone's transaction and what they want to do, like here's their address, their public address, here's the transaction data, here's how much gas that they want to pay, here's the fee that they want to pay to be able to kind of promote that and kind of prioritize that. And what happens is this fills up with so many requests every X amount of seconds. So like on Ethereum, it's like every 15 seconds, a bunch of transactions get kind of pulled together, and someone picks up those transactions and verifies and validates those transactions. So what happens is there's just this little amount of lead time where someone else can see those transactions, and then they can make decisions about maybe making their own transaction with additional gas fee or additional fee that's more than what's in the pool, so that their transaction gets picked up ahead of another one. And so this is why like it's very hard to do like randomness on the blockchain. Or I should say it's hard to do like exposing like some kind of random data, because if you're going to submit a transaction and you want to like, it's your answer and it's in that transaction, someone else could see your answer and get that transaction ahead of you and maybe like win a pot of Ethereum or win some kind of transaction. So this concept of the pool is just susceptible to that because it is open and visible, right, for anyone to see.
That kind of seems like quality of service based futures speculation.
Yeah, exactly.
Yeah, I guess you'd really have to know something is coming up in that scenario. Interesting.
Well, it could be something just as simple as like maybe you see that someone's making a large transaction where they're going to profit on the transaction. Maybe they're going to do some like there's a concept of what's called flash loans, where you can actually like borrow some money and then purchase something and then pay it back by the end of the transaction in the same pool. And so people will do like flash loans, and they'll like try to do like a transaction that's worth it for them. So they'll pay some gas and then make some money. And if you have more capital than the other person, you technically could front run their transaction and beat them on the price and beat them on the opportunity. So that's when you see front running, it's kind of like a common issue.
So
It's
yeah,
like
so that's all the people who with money make money, right?
Yeah, I mean, it's kind of analogous to like electronic trading at this point, right, where you're writing algorithms to kind of beat the system and make trades that humans cannot. Maybe what we'll do from here, we will link the article down below from wherever you're watching from right now. And there's lots of great info on there. But Kevin, maybe you can tell the audience where else they can find out more about this and where they can get in contact with you if they have other questions.
Yeah, so I'm available on Twitter. That's probably where I'm most active. My Twitter is cryptomastery_. And that's a good place to kind of like, in general, like we call it crypto Twitter. That's where a lot of crypto people hang out and kind of learn from each other. There's also a lot of interesting conferences coming out around Ethereum. So like ETH San Francisco is actually this week in San Francisco. It's actually SF Blockchain Week. And there's lots of traveling conferences as well. So look up Ethereum trend conferences in your area and try to get involved if you're interested in kind of building smart contracts or this new concept of like Web3 and decentralization.
Very good. Thanks a lot, folks. We will also link Kevin's Twitter down below. And otherwise, thank you very much for joining us, Kevin.
Thank you.
Yeah, thanks a lot, Kevin. I always learn something. It's great.
Yeah. See ya.